All right. So last time we had talked about solving right triangles, a little bit of review of things that we did in our geometry course from many moons ago. And then I presented you guys with two techniques that we can use in non-right triangles, the law of sines and law of cosines. And we talked about the scenarios that we can use, or the situations where we want to use the law of sines versus the law of cosines. Before I dive in and do some more examples, I thought to myself yesterday after class, I'm like, we should have probably drawn some pictures to make sure we can tell the difference between like angle side angle and angle side or something, because if it's been a while since geometry, maybe that's not fresh in our mind anymore. So I want to take a minute and just kind of do that. So let's say that this is our triangle where the highlighted are the givens. So we have two given angles and a given side. Is this angle side or angle side angle? Angle side angle. Very good. The way we can tell is that the given side is a part of both angles. Right? You guys can see that? As opposed to something like this, which would be angle side, because the given side is not a part of both angles. Yes. I think you have to probably go down to the bookstore to get that. Okay. Okay. I don't think they give them to an IT. I think you have to buy them from the bookstore. What about this one? We have two sides and an angle. Is this side angle side or side angle? Side angle side. Again, you can tell because the given sides make up the given angle. So this then has to be that side angle. You can notice that one of the sides is not part of the given angle, right? And it's the side angle side and side angle that it's really important that you're able to tell the difference between, because one of them is a law of cosine situation, the other is a law of sine situation. And then the last situation is the one that nobody can ever screw up. Side, right? There's never any confusion on that one, what that is. So if you look at those 5 situations and you think back to your geometry course, which one of them is like doesn't belong? It's not side. It's the side angle situation. The other 4 were congruence or similarity theorems, but there is no congruence or similarity theorem for side. Let me kind of demonstrate to you why. So they'll do this geometrically. So I'm going to just kind of construct a little picture here. So I'm going to draw a side situation, or I'm sorry, a side angle situation where you have 2 distinct triangles that both have that same side angle congruence but are not congruent triangles themselves. So here's a side that has length 12. And here's a 48-degree angle, because this is like the third side of our triangle that we don't know how long it is. I'm going to use a line or whatever for it. Zoom that up a little bit. And then I'm going to draw a 10-unit side. And to do that, I'm going to really make a circle with radius 10. And notice there's two places that that circle can intersect the third side. So what that's really saying is, if I take this point here, point C, and make a triangle, that triangle ABC has a side length 10, a side length 12, and then a 48-degree angle. But if I also make this point D, and I form the triangle here, ADB, this is a triangle with side length 10, side length 12, and a 48-degree angle. We have two triangles that both have that side-side angle congruence, but are distinctly not the same triangle. This is why there is no side-side angle congruence theorem in your geometry course, because it doesn't guarantee you have congruent triangles. You could have two separate ones. Now, as this angle here, the given angle here, angle B in our drawing, gets bigger, these two lines are going to get closer and closer together. When that angle B becomes 90 degrees, they are then the same line, and only one triangle is possible. So triangle congruence does hold in that case. You had a special name for that situation in geometry. I think your textbook called it the Hypotenuse Leg Theorem. That rings a bell or not. But that was the special case for SSA where the angle must be 90 degrees, and then congruence does hold. Triangle congruence does hold. Okay with that? So again, when we start dealing with the side-side angle situation, which we're going to start here next, we're going to have to be very careful because weird things can happen. Okay. Yesterday we did an example of I don't remember if it was an ASA situation or an SSA or an ASA or an AAS situation, but they're basically both the same kind of problem where you just use the law of sines and you bulldoze through it and it's not a big deal, right? You remember doing that at the end of the hour? Today I want to take some time and talk about this SSA situation. In some contexts, people call this the ambiguous case. Because if under a certain set of conditions, lots of things can happen. So for our purposes, let's say that we have this is our SSA situation. So we have angle A, side AB, and side BC. Just for naming purposes, that's what I'm going to name these sides that are, or sides and angles that are given to us. Everybody's okay with that? So it turns out there's three cases. So if angle A is obtuse, and then the sides AB and the sides BC, three different things could happen, right? One could be bigger than the other, or they could be equal. So if angle A is obtuse, what does obtuse mean again? Greater than 90 degrees and less than 180 degrees, right? If angle A is obtuse, what does that mean about the side BC? It has to be the hypotenuse, right? Everybody agree with that? Because you can't have another angle in the triangle that's bigger than A. You can't have two obtuse angles in the same triangle because you only get 180 degrees to work with. Everybody agree with that? So if BC is the biggest side, then one triangle is possible. There's nothing else to worry about. If BC and AB are the same length, what does that mean? Is that possible? No, it can't be possible. That's not possible because the BC has to be the hypotenuse. So there's just no triangles possible in that situation. Similarly, if BC is smaller than AB, again, BC has to be the hypotenuse. So no triangle is possible in that situation either. So that's not so bad, right? If it's an obtuse triangle, or if A is obtuse, then all I have to do is make sure that that side opposite A is actually the hypotenuse, is actually the longest side. And otherwise, there's nothing I can do with it. It's a, you know. So if angle A is 90 degrees, really the same thing holds, right? BC has to be the hypotenuse because you can't have another angle in the triangle that's bigger than 90 degrees or equal to 90 degrees. So it's just the same set of situations. As long as BC is the biggest given side, you're good. There's just one answer. Otherwise, it's impossible. I guess I should probably put a plural, right? Zero triangles. Grammatically speaking, that should probably should be an S at the end of that. Zero triangle doesn't make grammatic good sense. That sounds wrong to me. Not that I'm the grammar police by any means, but, you know, technically correct is the best kind of correct, so. All right. The last situation then would be where A is acute. And here, if BC is the biggest side, that's okay. Just one triangle is possible. If they are equal in length, that's okay. Just one triangle is possible. But if BC is the shorter side, then kind of all heck breaks loose. And it's unclear immediately from just looking at your information whether you're going to have 0, 1, or 2 triangles possible. So the first thing we'd want to do now is we want to figure out a way to tell, well, should I be looking for no answers, one set of answers, 2 sets of answers? If I run into this situation, so this is how we're going to tell. So we're going to set up a law of sines. So if I look at what I've done, my law of sines would be like sine A over BC equals sine C over AB. Everybody agree that that's how I would set up my law of sines for the way we've named things here? And C is the piece angle C is the piece we don't know currently. Everybody agree with that? Okay. So I'm just going to go and cross multiply this. Oops, let's write it in the other order. And then we'll get the sine C by itself. And now, whatever this number comes out to be, that's going to tell us how many triangles we have. If that number is bigger than 1, no triangles are possible. If that number is equal to exactly 1, one triangle is all we can get. If that number is less than 1, we get 2 triangles. Another way to interpret this would be longer side times sine of the given angle divided by the shorter side is maybe sometimes an easier way to thinking about that. Okay, so let's do some examples now, right? This is a fairly complicated process that we've just kind of described. A lot of things can go on. So let's go through and take a look at what's going on and sort through this. Can you not read something?
Yeah, wait, what is it saying in parentheses?
Given angle.
Oh, okay. Gotcha.
Yeah, no problem. If you ever can't read anything, like holler at me. I fully acknowledge that my penmanship is less than spectacular at times. So I don't have any ego about it if you can't read it. Probably somebody else can't either, and it's worth clarifying. I don't know if the more of a dot on the I was it's probably the angle symbol at the end where you just weren't expecting a symbol there. You're expecting a letter. What the heck is that? Is that an L? What is given L? Yeah. No, I get it. Yes, Sydney. 19. Okay. So let's start by drawing our picture. So we have angle P. If we have a side Q, we also need an angle Q. And then I guess we need to pick another letter. I would reasonably pick R because the alphabet. Now remember the way we named our triangles where the side opposite the angle gets the same name. So that side needs to be P. That side needs to be Q. And that side needs to be R. Everybody feel good with the picture we've drawn? Okay. Which situation are we in? This is the side-side angle situation, which means we're going to be using the law of sines. But the side-side angle situation requires a little bit of extra checking. So angle P, is that obtuse, right, or acute? Acute. And then Okay, after we've checked that, we need to check or compare the two sides. The side opposite P, is that the biggest or smallest side? Is it the bigger or the smaller? The side opposite the angle that we're given. That's smaller, right? So this is that yucky situation where we can get 0, 1, or 2 triangles. Everybody's cool with how we analyze that? Okay, let's figure out whether we should be looking for 0, 1, or 2 triangles then. So I have the longer side times sine of the given angle divided by the shorter side. So I didn't write the 56 in here. So I'll go type that into my calculator. What mode should my calculator be in to do this? Degree, very good. How do you know it should be degrees? Because the angles are in degrees. Very good. Again, I know that these are dumb questions that I'm asking and you know the answers, but I just like to remind people. So I get 0.984-ish. Since that's less than 1, I know I'm going to be getting 2 triangles. You feel okay here? And how I was able to analyze that this was going to give me 2 triangles? Okay. So I'm going to make up a space to write down my answers for both of these 2 situations. I'm going to name I'm going to put a subscript on my angle Q, angle R, and side R to differentiate the answers in one triangle versus the other triangle. But in both triangles, the values for angle P, and side Q are the same. The things that are going to be different are the values for angle Q, angle R, and side R. Everybody okay with what I've written up here? Just a place to write down my answers as I find them. Typically, what I notice from students is that organization becomes an issue for this kind of problem because there's a lot of sets of answers. Making sure we're getting the right stuff in the right spot matters. So I think that it's well worth your time to make a little space for everything right from the get-go. So you remember to find everything and you're able to pick the right stuff to use for the right problem. Okay. And then I'm going to make a space for my work. So my work for triangle 1 is going to be over here, and my work for triangle 2 is going to be over here. Again, just trying to stay organized so that I don't mix up, the answers for one triangle with the answers for another triangle. You know what I mean? Okay. So I'm now for triangle 1 going to approach this exactly the same way that we did yesterday. So I'm just going to start with sine P over P equals sine of Q1 over Q. Note that I knew I had to solve for Q1 first because I don't know R, angle R or side R, right? So I know that I have to start with angle Q. Everybody's good with that? Just the law of sines. So we'll cross multiply. So 16 times sine Q1 equals 19 times sine 56. And then we'll divide both sides by 16. And then how do I get rid of the sine in front of the Q1? Sine inverse. Yes, exactly right. So Q1 is going to equal sine inverse of 19 sine 56 divided by 16. And again, I'm going to leave it, I'm not going to like calculate any of these intermediate values. I'm just going to leave this as all one thing that I type into my calculator. So sine inverse. And I'm going to use the fraction command so I don't have to really worry about any parentheses or anything here. Not that the parentheses are a big deal, but like, you know, just one less thing to worry about. If I can just type it in exactly like it looks on my sheet of paper, I know that I wrote it on my sheet of paper correctly, so the calculator should do what I want it to there. Thanks, Ben.
Yes, sir.
Jillian, it's for you. Yeah. You're my only Jillian.
Thank you.
You're welcome. So I got 7989 here. So let me go record that up here. Now that I have angle P and angle Q, angle R is easy to find, right? And just do 180 minus 56 minus 7989. Everybody happy with that? So that's 44.11. So far, so good. Again, this is pretty much identical to yesterday, right? When we just used the law of sines. Nothing tricky has happened here. The tricky part is all really done in the beginning in sorting out what the heck was going on. And now to solve for side R, I can do that now that I have angle R. So I can do, again, sine P over P equals sine of R over R. Again, we'll cross multiply. And then divide. And then it's calculator time. (16 times sine 44). Let's actually use that. Just steal the value. So that gives me 1343. So 4411. And then 1343. So that's all of triangle 1 is finished there for us. And this is the way that I usually prefer to work. I'd rather do all of triangle 1 and then do all of triangle 2. I think I get less mixing up of stuff if I do it that way rather than jumping back and forth between the two. But you could do that if you prefer. It's not wrong. And I'll give everybody a minute to catch up here before we go and talk about how we go about getting triangle 2, which is actually less work than triangle 1. Which is nice, right? Okay. So triangle 2, this is the place where there's significant shortcuts. Q2 is always going to be the supplement for Q1. So 100.11. Woo! That's pretty easy, right? Which is great because now for R2, I know P and I know Q2. So that's easy. So 2389. Woo! That was easy. And then the last step is going to be exactly the same as what we did in triangle 1. So sine P over P equals sine of R2 over R2. And then we just cross multiply and all that jazz, and it's the same work. What do you think on this? It's not so bad once you get through that first analysis to figure out what the heck is going on. So let's see, R2 is 782. Okay, forgot to write any of that stuff down. 100.11, 2389, and then 782. We'll go back down here. And this is the worst case scenario problem here, is where you have the two triangles. It's the most stuff you'd have to do. And in fact, I think this is the hardest single thing that we do in this chapter, is what we just did here. Which, if you can handle this, it's not so bad. The hardest part, again, is making sure that you identify the two triangle situation correctly. That's really the hardest part. But again, the check on that is it SSA? Yes. Is the angle that I'm given acute? Yes. Is the side opposite the given angle the shortest side? Yes. That's the only time you really have to think, worry too hard about it. Everything else is pretty common sense, either 1 or 0. Okay. Let's do another example. Yes, Regina.
Maybe
Of course. Yeah, no problem. So here we have a triangle with whose angle A is 74 degrees, side A is 2.5 units, and side C is 4.9 units. So we'll start by drawing ourselves a picture. So obviously one angle is A, another angle has to be C because we have side C. So what should I name my other angle? I would name it B because the alphabet. So this has to be side A, this has to be side B, this has to be side C. And I'll fill in the values that were given into my picture. Again, we notice that this is the Ssa situation. That tells me I should be using Law of Sines to do this. Next thing in the Ssa situation is I want to check that given angle. I notice it's acute. So then I want to check or compare the lengths of the two sides. Is the side opposite our given angle, is that bigger or smaller than the other given side? Smaller. So that's the 0, 1, or 2 triangle situation. Everybody's cool so far on how we figured that out? It's a couple of things we need to check, but none of them are too hard to check. The hard part is remembering what it is, what the rule is. But like the check itself, you're just like using inequalities basically. It's like not that bad. So the check here, we take the longer side times sine of the given angle divided by the shorter side, and we're going to check what that value is. When I do that, I get 1.88, which I'm pretty excited about. Since that's greater than 1, I have 0 triangles possible. So I'm done. There's nothing to do. There's no triangle possible, nothing to solve for. Game is over. All right. Rock and roll. Yeah, party on, dude. Everybody happy with this? So, again, sometimes it's really bad, like the previous one where there's a lot to do. Or sometimes it's really easy because there's nothing to do after you figure out that there's no triangle possible. That's pretty cool. Cool. Okay. Do we feel okay on this SSA situation? We've done a couple of examples here to show how things work out. I don't want to do like an example of every single situation because shoot me in the head, that's a lot of examples to run through and you'll be pretty bored pretty quick. But I hope we've done enough that you got a pretty good idea. Of course, when we start on the homework, if you get to a point and you're like, yo, I'm stuck on this stuff, we can certainly go back and do some more. Okay. So let's kind of just keep the ball rolling here. We'll do another example. Okay. So here we're given that angle A is 34 degrees, side B is 14 units, and side C is 17 units. So let's go ahead and draw a picture here. Pretty obvious that I'm naming things A, B, and C. Okay. Everybody cool with the picture? What situation is this? Side angle side, very good. Which tells me that I should be using the law of cosines. So in the side angle side situation, the piece that I'm solving for first has got to be the side opposite the given angle, or just the only side that I'm missing. So using the law of cosines, I have a squared equals b squared plus c squared minus 2 times times b times c times cosine of a. So that's just me filling in the formula. To get the a by itself, then I'm just going to square root both sides. And again, I would do this just as this, type into my calculator exactly as I've written it. I wouldn't do any intermediate arithmetic. I just let the calculator handle the whole thing for me in one shot. So when I do that, I get 9.51. Okay, so now we either have to find angle B or angle C. Yes, Maddie? Sure. To find angle B or angle C, I would use the law of sines because the formula is considerably less complicated than the law of cosines. You could use the law of cosines still. I would not, personally. Everybody's okay with that? And I can use the law of sines now because I have an angle and its opposite side, right? So the question becomes, does it matter whether I solve for angle B or angle C next? Well, the answer is only if you want your life to be easier, then it definitely matters. So what we want to avoid here when doing this is stumbling into an ambiguous case situation, which you could get because using the law of sines at this point is a side-side angle situation. To avoid the ambiguous case, I would find the smaller angle next. So between angle B and angle C, which one has to be smaller? B, because the side opposite B is smaller than the side opposite C. So let's find angle B next. Let's write a note here, though, that says what we did. So just make a little note for ourselves if we're going back and looking at that, because we really want to make sure that we avoid having to do handle any ambiguous case in here if we don't have to. By doing it this way, you're guaranteed a one triangle situation, which is what we want, right? We don't want to run into a two triangle situation, be like, ugh. Okay. So we have now sine of A over A equals sine B over B. I cross multiply. And then we divide. And then we do the sine inverse. And now it's calculator time. Everybody feel okay on what we're doing here? So I get 5544 when I do that. So then angle C, super easy, because now I have two of the three angles. So 90.56. Feel okay here, guys? The only tricky part here is just remembering at that second step when we break out the law of sines to make sure that you're finding the smaller of the two angles next. But that's the only really tricky thing here. Otherwise, it's just plugging through formulas, right? Little bit of light algebra. All right. One more example here. So clearly this is the side, side, side situation. However, in the side, side situation, or side, side, side situation like this, we can't bulldoze straight ahead into the law of cosines. Because we don't even know if these three sides can possibly make a triangle. Right? For example, if I gave you said, oh, triangle with sides 1, 1, and 100. If you think about that in your head, is that going to fit together into make a triangle? Heck no, you can't make a triangle out of that stuff. So before we get going here, we need to figure out, is there even a possibility that there's a triangle here? So the check that we need to make is to make sure the leg plus leg is greater than hypotenuse. How do I know which one's the hypotenuse? It's the biggest one, man. So 5 plus 8 is bigger than 12 or bigger than 10? That's correct. So triangle's possible. We're good. We can proceed. Everybody feel okay with that? Now that's easy check to make, but you got to remember to do it, because if this was, 5, 8, and 15, you're just going to be banging your head into the desk going, why isn't this working? Why do I keep getting an error in the formula? Blah, 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 on my calculator. And I don't know. I don't get what's going on. It's because you have something that's an impossible triangle. Okay. So we need to find angles P, Q, and R. Next question is, which one should I do first? And does it matter? Well, here's what I'll tell you. It matters if you want to make your life easier. The goal here, again, is going to be avoiding the ambiguous case later on. The way that we do that is that we're going to find the biggest angle first. Which one is going to be the biggest angle? Very good. R is correct. How do you know that R is the biggest? Because R was the biggest side, right? Means R is going to be the biggest angle. So just as a quick summary, law of cosines, if you're finding an angle, find the biggest angle first. Law of sines, if you're finding an angle, you find the smallest angle first. That'll avoid ambiguous cases for you. Now you need to remember that, but I mean, it's not complicated and just something else to remember. Okay. Number one mistake I see students make here is an algebraic one where we combine all the 5 squared plus 8 minus 2 times 5 times 8 all together. Why can't you do that? Yeah, that stuff has a variable attached to it, so you certainly can't combine it with non-variable things. My suggestion to you is to not do any simplification. I would move everything over and let the calculator handle the order of operations all at once. So I would subtract the 5 squared over and the 8 squared over. And then divide over the 2 times 5 times 8. I should say negative 2 times 5 times 8. I don't think I said the negative. That's also a fairly common mistake, is students dropping the negative and then getting all kinds of kooky errors. Everybody's good so far? And we'll just do the cosine inverse to both sides. And here's a place where I'm definitely using that fraction command on my calculator, because without it, that's a mess of parentheses to have to sort through on my calculator. The fraction command dramatically decreases the need for parentheses there. So I definitely want to be making sure that I'm comfortable using that command, because it saves me all kinds of calculator headaches doing that. So I get 97.90 as my angle. Now we're basically back in what we had before. So we're going to use the law of sines again to solve now the smallest angle. Just like we did on the previous problem, whenever we go to the law of sines, let's find the smallest angle first. So we're going to do sine r over r equals sine p over p. So cross multiply, sine p equals 5 times sine 97.9. And then divide both sides by 10. And then sine inverse both sides. And it's calculator time. Da-na-na-na. Beep, beep, boop, boop, boop. And I like using that ANS command rather than typing in the rounded answer. It's just faster, you know. So what do I have there? 20, 29, 69? And my last step then would be angle Q, but that's really easy because I have the other two angles. So 5241. Okay. Let's pause here for a moment. How do we feel so far? Again, typically, not too bad, right? You're mostly just using formulas. There's a little bit of intricacy about like how to use the formulas and when some stuff can happen, when weird stuff can happen. But the most of the work is just like grinding through the same formulas over and over and over again, which is not so bad. I think I'm going to stop here even with 20 minutes left because there's just one section left in this chapter. I don't want to finish the whole chapter all today because I want to have something to do next week. You know, before having like a homework quiz and a test or something right back to back, which is what it's looking like for next week, just FYI. So at this point, you guys should be able to do like 1 through 22, and you should be able to do worksheet 1. Now, none of this stuff is due for Sunday's problems or homework check. There is no homework check on Sunday. This will all be part of next week's homework check because I know you don't want to do a homework this weekend. Don't worry about it. You've got enough catching up to do with getting used to being back at school again. And I don't want to do it. So we'll just push it into next week. For sure, next week you should be planning on a homework quiz one of these days. So I would do some of this homework this weekend for sure to make sure that like I have a pretty good idea what's going on. I would say you don't need to worry about memorizing the formulas for the homework quiz. I would give you the law of sines and law of cosines. Now, you should be able to use them and know the rules about like when there's how many triangles and all that jazz. That I would expect you to have, you know, have that part memorized. But the formulas themselves, I would give that to you. And probably won't have the test next week. It'll probably be the week after, since we only have 2 days together next week, right? Because this is A day. So next week we just meet 2 times. So I'll probably do the, you know, like the last chapter or the last section, and then either take the homework quiz and the next day is the review day, or finish the last section and then do the homework quiz and review on Thursday. I don't know. It doesn't matter to me which one we do. We can figure it out on Tuesday. But that'll be the agenda for next week. Does that feel good? Everybody got a good idea of what's going on and what you need to be doing and where we're at. So be test beginning of the week after, homework quiz next week. The homework set in general is pretty short. I think there's only like 29 problems or 30 problems or something in this chapter, so there's not even that much to do, which is pretty good. Although some of these problems can get a little bit time consuming because they can be long. If you catch a 2 triangles problem or something, that can be long. I do want to say one little quick thing about the problem set. Just make sure that you're reading the directions carefully. For example, on 5 through 10, they're just asking whether there's 0, 1, or 2 triangles. They don't need you to actually to solve the triangle. So don't do more work than you need to on that. All you need to do is figure out whether there's 0, 1, or 2 triangles possible, and then just move on. Don't actually find the values for those triangles. You know what I mean? So just be careful reading the directions and not like turn something that's an easy problem or a short problem into a long problem. I don't want to use the word easy. Okay. Okay, let's see. Let's start writing some of this stuff down. So the 16th is next Sunday. Again, I'll keep adding on to this as we assign new things, but for right now, the next problem set, or on the problem set for the 16th, that'll be our first problem set of the year. And then we're looking at, so the 17th, I think, will probably be the test day. Oh, we don't, do we? Yeah, that's Martin Luther King Day. Yeah. And I'll get this stuff in the grade book on the calendar later today so that you guys can see all that.